All right, welcome back. We're going to do two more examples where we kick it up a notch. And then in the last video after this one, we're going to do the other main concept that we need to cover. So we're just continuing on with examples. Let me get the grid going here. Of using implicit differentiation. So for example, let's do the equation sine of y plus cosine of x is equal to y squared. And I want to find dy dx. And just as a reminder, I'm going to put up in the corner here the rule for differentiation of sine of u. So the derivative of sine of u is going to be cosine of u times u prime, which is du dx. So in this particular case, the u happens to be a y in this equation. So I want to find dy dx of this equation. So step one is I'm going to take d dx of both sides, and I'm going to distribute if I've got sums and differences, not if I have quotients or products. So I have d dx of sine of y plus d dx of cosine of x is equal to d dx of y squared. Okay, so let's take this each piece at a time. So I've got d dx of sine of y, so different, I have to include the chain. So I'm going to use the chain rule that I have up here, over here, up in the upper right hand corner. That's kind of dumb. All right, I'm not going to do that again. Okay, so now, so here's what we're going to do. I've got the derivative of sine of y. It's just like doing the derivative of sine of u. So the derivative of sine of y is cosine of y times y prime, which is dy dx. Plus, I've got the derivative of cosine of x with respect to x, same. So the chain is 1. I'm not going to write it. So the derivative of cosine of x is minus sine of x. And that's equal to the derivative of y squared is going to be different. So it's going to be 2y times the chain, dy dx. Okay, step 2. This is actually not as difficult as like the last one. So I want to get everything touching a dy dx on the left-hand side and everything else on the right-hand side. So I'm going to subtract by this 2y dy dx term. So I've got cosine of y times dy dx minus 2y times dy dx is equal to, I'm going to bring this term over to the right-hand side, so I'm going to add sine to both sides. This is equal to sine of x. Then I'm going to factor out a dy dx from this term here. So I've got, I'm going to factor out the dy dx, and that leaves me with cosine of y minus 2y is equal to sine of x. And then just solve for dy dx. So dy dx is equal to sine of x over cosine of y minus 2y. Done. Boom. All right. Not too bad. But again, just make sure you can reproduce these. Let's kick this up a notch. And these are a little more difficult. All right, so let's do this one. So for example, let's say I have sine of x squared y cubed minus 8 over y squared is equal to 5x to the third. Okay, the first thing I want to do is before, and of course I want to find dy dx. So what I want to do first is, you see this term right here. You don't want to use the quotient rule because you can actually write that so you can use the power rule. So I'm going to rewrite this equation before I start. Sine of x squared y cubed minus 8 times y to the minus 2 is equal to 5x cubed. Okay, so now I'm going to use implicit differentiation. So step 1 is I'm going to take d dx of both sides. Okay, so if I do so, I've got d dx of sine of x squared y cubed minus 8, I'll pull the constant out, minus 8 d dx of y to the minus 2. And that's equal to, I'll pull a 5 out, 5, and then d dx of x cubed. Okay, so right away you can kind of tell that these two terms here are going to be the easier ones to differentiate. So I'm going to do that first, and then I'm going to go back to the harder one. So let's start on the right-hand side and work backwards. So here, if I've got the derivative of 5x cubed, then this is going to be equal to 15x squared times the chain, which is 1, because you got same. Going over to the left, the derivative of y to the minus 2, so I've got minus 8 times the derivative of y to the minus 2. So that's going to be minus 2 y to the minus 3 times the chain, which is dy dx. And I'm actually going to write that as there's two minuses, so it's going to be plus 16 over y cubed dy dx is equal to 15x squared. Okay, so now let's go over to this guy here, which is the harder one, because I've got the derivative of sine of something. So this is one's going to be a little bit tricky. So the derivative of sine of something is going to be cosine of that thing times the derivative of that thing. So the derivative of x squared times y cubed, that's a product. So I've got to take the derivative of what's inside here. So let's go back up here. So I've got to take the derivative of x squared times y cubed. So the first term is x squared, second term is y cubed. So the product rule is the derivative of the first, which is 2x, times the second, which is y cubed, plus the first, which is x squared, times the derivative of y cubed. And the derivative of y cubed, with respect to x, is 3y squared times the chain, dy dx. Okay, so now this is, once again, messy. So I need to isolate my dy dx. So I'm going to multiply out here, boop, and boop, and so I need to multiply out in order to isolate dy dx. So I'm going to multiply that out and write out the whole thing. So I've got 2xy cubed times cosine of x squared y cubed plus 3x squared y squared times cosine of x squared y cubed times dy dx plus 16 over y cubed times dy dx is equal to 15x squared. Now, as I mentioned, now is a great, as I mentioned before in the problem a couple times ago, is let's get rid of fractions right here and now. So here, what's causing me to have a fraction is this y cubed. So I'm going to multiply every single term by y cubed. So if I multiply this first term by y cubed, then this becomes y to the 6. And if I multiply the second term by y cubed, this becomes y to the 5th. Because remember, you're adding exponents if you're multiplying them. And if I multiply this third term by y cubed, the y cubed goes away. And then this last term on the right-hand side, this becomes y cubed. Okay, so I'm going to erase up to here. And let's go back up to the top. All right, good. So let's rewrite this whole thing. So I've got 2x y to the 6 times cosine of x squared y cubed plus 3x squared y to the 5th cosine of x squared y cubed dy dx plus 16 dy dx is equal to 15x squared y cubed. Okay, now we're in business. So what we want to do is isolate all the terms that have dy dx and get those on the left-hand side. And cool, actually they both are. So the only thing I really need to do here is I need to take this term that doesn't have a dx dy, or sorry, dy dx, and bring it over to the right-hand side. And so I'm going to take that over to the right-hand side, and then I'm going to factor out a dy dx on the left-hand side. So I've got dy dx, and I'm factoring out these two terms in red up here. So I get 3x squared y to the fifth cosine of x squared y cubed plus 16, and that's equal to 15x squared y cubed minus 2xy to the sixth cosine of x squared y cubed. All right. Last but not least is I need to solve for dy dx. So I'm going to divide both sides by this term that's touching dy dx. And again, it's just there's a lot of algebra here, so you have to be really careful with your bookkeeping. All right, so dy dx is going to be 15x squared y cubed minus 2xy to the sixth cosine of x squared y cubed all over 3x squared y to the fifth cosine of x squared y cubed plus 16. And let's see if I can factor out anything, because I do want to simplify. Now on the bottom, because I've got this 16 by itself, wait, something... Okay, that's right. So I got the 16 by itself, and so I can't factor out an x or a y. But on the top here, I can factor out 1x and 3 y's. So if I do so, then I get dy dx is equal to, I'm going to factor out an x y cubed on the top, and so that leaves me with 15x minus 2y to the third cosine x squared y cubed, all divided by 3x squared y to the fifth cosine of x squared y cubed plus 16. All right, messy but done. Again, make sure you can reproduce these, and we've got one last video, and then that is it for section 2.5. See you soon.